All right, I hope you had a nice break, and we've just been sitting here, just working really hard. And I hope you guys are home working really hard. Now, we need to talk about something that's really important. And what is that we're going to talk about? Thank you. Significant figures. Thank you. Significant figures. Did you guys read about this last night?
Yeah.
Significant figures. Did they talk about this last year?
No.
A little bit.
Super important, super complicated. You guys are very lucky that I'm your teacher because I explain this very well. There are a few things that I explain very well. This is one of them. All right, I've mastered how to explain significant figures. Okay, significant figures. Here's the deal. Okay, I have, and it has to do with accuracy and precision. So I have three, what are these things called?
Beakers.
Thank you, graduated cylinder. You did not say beakers.
I did.
Graduated, I know you did. Graduated cylinders. There's a 500 milliliter graduated cylinder. Each one of these lines, it says 455. Each one of these lines represents 10 milliliters. So each line represents 10 milliliters. There's a 100 milliliter graduated cylinder. Each one of these lines, these little lines here, represents 1 milliliter. This is a 10 milliliter. Each one of these lines represents 1/10 of a milliliter. Okay? Now, which one is most precise?
The smallest one.
The smallest one's going to be most precise. If I'm taking a reading from the smaller one, I can get pretty precise, right? If I take a reading from the big one, I'm not going to be very precise. Okay? Significant figures tells us how precise it is with the reading you've been using. That's what it does. It tells you how precise is the reading that you have been reading, that you've been doing. So I can't use this and confidently say that I'm within a milliliter, that I'm within 1/10 of a milliliter, because each one of these lines represents 10 milliliters. Whereas if I use this, I can confidently say that I'm within 1/10 of a milliliter. So this has to do with precision, but it also has to do with accuracy, because hopefully if you use something that's more precise, you can get a more accurate answer. Everybody with me? This is what I want to do. I want you guys to figure out for me the volume of this classroom. Now what I'm going to do is I'm going to use, this is all hypothetical, imaginary. Just imagine for a second. Close your eyes. Imagine that we are going to take the volume. You can open your eyes now, Jess. We are going to imagine that we're going to take the volume of this. We know volume is equal to what?
Mass times time. No, time over mass.
Okay, listen. All right, let's try this again. I don't want anybody in the back row answering this question.
Base times width times width.
Length times width times height. Thank you. Thank you.
I don't know. I was thinking.
Thank you. All right, we are going to get the volume, and I'm going to use a meter stick. Okay, I'm going to use a meter stick that is, and I don't have one right here. I'm not going to use a meter stick. The hell with that, right?
You can use Mr. Mills like the poking stick.
I'm going to use, I could use the poking, I could use the poke, I'm going to use the poking stick. I'm going to use a meter stick. And my meter stick is divided up, it's just 1 meter long, yes?
Yeah.
It's just 1 meter long. So I measure from here to the back, and I notice that it's about 11.5 meters, okay? So I'm going to say it's 11.5 meters, okay? Then I'm going to measure from one side to the other side, and I'm going to say, boy, that's probably 19 point, well, it looks like it's close to the whole thing. I'll say it's about 19.8 meters. Then I'm going to pretend that this is flat, and I'm going to measure up to the height, and I'm going to say, boy, that one's about it's almost 19, so I'll say it's 18.9 meters. Okay? Now, I want you guys all in your calculator to find out what's the volume. And at home, I hope you're doing this also. What did your calculator say? What's the number your calculator says?
4,000.
Give me digits.
4303.53.
4303 what?
0.53.
0.53. Did anyone else get something different on your calculator? Because calculators will give you different numbers. Did anyone get a different number? Okay. This number tells me to the 100th of a meter what the answer is. Yes? How can I have that kind of accuracy when the precision that I've used only goes to a meter? Does everybody understand that?
Yeah.
This is a fake number. It's like fake news. It's a fake number. It's not as precise as it's making it out to be. Because your calculator doesn't know it. Your calculator is like for math people who don't care about this stuff. Because they don't care about units. They only care about numbers. All right? I'm not dissing math people. I'm just saying that they're incomplete. Okay? When math people start using numbers and units, then they'll be complete. All right? You can tell that when you have a day at your math class and the teacher seems to be incomplete, you just say to them, you're missing units. All right? Here we go. Calculators do that. What significant figures does is it tells us how precise is the thing that we used. All right? How precise is the thing that we used? So what we have to do is we have to have a way to figure out how precise is the numbers that we used. So when we use them, especially in calculations, we need to condense it to the right number of significant figures that tell us how precise is the reading that the instrument that we used. All right? So for starters, if we're counting something, I'm counting students, 1, 2, 3, 4, 5, 6, 7. All those are infinite numbers of significant figures. Anytime you're counting something, you have unlimited number of significant figures. Because in reality, if there are 15 students, it's 15.0000 forever. Yes? If you're measuring something, there's always one more place that you could do it to. So everybody with me on that?
Yeah.
If you're counting, it's unlimited significant figures. If we're using a conversion, it's unlimited significant figures. So when I say 1 minute has 60 seconds, those numbers have unlimited significant figures. Yeah.
I don't get how that number with the 0.53 is less precise than like if it was just 4,303.5.
Well, in fact, this number, even that is going to be, what it should be, and I'll explain to you, is 4,300. 3,000, excuse me. That's what the answer should be. Nope. The number should be 1, 2, 3. It should be 4.30 times 10 to the third. It should be 4.3 times 30 times 10 to the third. And I'll explain to you why it should be that. Okay? Based on what we use to measure. Okay? I'll get to that. Does everybody understand about significant figures? If I'm counting, you have unlimited significant figures. If I'm using a conversion factor, you have unlimited significant figures. But if you are measuring something, it's not going to have unlimited significant figures. There's only a limit to how accurate that can be, how precise that can be. Everybody with me on that? Okay. Now, significant figures are every number that, when we're trying to find the significant figure, they're every number that we are certain of plus one that we estimate. That's what significant figures are. Significant figures are every number that we are certain of plus one place that we're estimating. Let's do this. I've got a thingy here. I don't know. Whatever unit, what unit you want to call that? Feet? You want to call that feet? Why don't you make up a unit? Each distance represents a unit. What unit is that?
1 grace.
What is that?
1 grace.
1 grace? Each one is 1 grace. All right. I'm going to measure one of these. Now, I measure this right here. It goes to right here. Let me draw the line where it goes to. Okay. What is the size of my marker? 1.5 graces? Is that what you say?
Yep.
Yeah.
Okay. Significant figures are, am I going to say 1.51? 1.52?
No.
Significant figures are every digit that you are certain of plus one that you estimate.
1.5.
So significant figures are every digit you are certain of plus one that is estimated.
So the 1 would be the starting and the 5 would be the estimate.
The one I'm certain of.
Okay.
The 5 is my estimate. I can't say 1.50 or 1.57. I can't be that precise, but I can say 1.5. Now, the reality is, I would probably say 1.4, but that's okay. Everybody get the idea? When you measure something, if I'm taking this, and each line represents 10 milliliters, I can only say 460, which I know exactly of, 4. That last one, I'm estimating. Yes?
So for the example we used before, would it be 4.30 because we're estimating all of 0.5, 0.8, 0.9, so it would just be 4,000?
Yeah, I'm going to get into that in a minute. Yes. So here's my graduated cylinder, and this is 50, and this is 49, and this is 48, and I put a liquid in it, and the liquid goes to right here. What would you say it is?
48.5.
48.5.
48.5. 48 we're sure of, the 0.5 we're measuring. Now, how about if the liquid goes to right here?
50.0.
50.0. 0.0 is your estimate. Is everybody with me? Significant figures are every digit you are certain of plus one that you estimate. That's what sig figs are. Everybody with me now?
Yeah.
Now, when you see a balance that looks like this, and you see a number that says 47.3, which is estimated? The 0.3. It's 0.3. In reality, if I had another one that was more precise, it might say 47.29.
And then the 9 would be the estimate, and the rest would be certain.
In this case, the 9 would be estimated. How precise something is. Everybody with me? Okay. So now we understand, first thing, we understand what significant figures are. Why we have significant figures. The next thing is when we see a number, how do we know how many significant figures there are? Okay? So that's part 2. When we see a number, how many significant figures are there? You see a number, how many significant figures are there? Okay. What is this?
A dog.
Oh, right now.
America.
Thank you. America, United States.
Oh.
What is this right here?
Massachusetts.
Massachusetts. Thank you. Thank you very much. What ocean is over here?
Atlantic.
We should make up oceans.
Wait, is this all of the U.S. or just Massachusetts?
Yeah, exactly.
Oh, it could be. No, this is the whole United States. Come on.
It is.
What ocean is over here?
Pacific.
Okay. A, Atlantic, stands for absent. Pacific stands for what? Present. If the decimal point is absent, you start at the Atlantic side of the number, and you go to you start on the Atlantic side of the number, you go to the first non-zero digit, and every number plus every other number going cross-country is significant. Let me just show you what I mean by that. 42010, 42000. It is absent, yes? I start on the Atlantic side of the number. I go to the first non-zero digit, which is what on the first one? What's the first non-zero digit? 1. Starting the Atlantic side. First one, that number and every other number is significant. How many significant figures are in here?
4.
4. 1, 2, 3, 4. Second number.
Only 2 significant.
How many significant figures?
2.
2. Start the Atlantic side. Go to the first non-zero digit, and there you have it. Everybody with me on that?
Yeah.
If it is present, if the decimal point is present, you start on the Pacific side of the number. You go to the first non-zero digit, and every number after that is significant. 4.107, 0.0400, 0.0410. Each one of these has a decimal point. I start on the Pacific side, yes?
Yes.
Right here. First non-zero digit is right here. How many significant figures?
4.
4. Next number. Decimal points present. How many significant figures?
3.
3. Next number. How many? 3. Present, Pacific side of the number, first non-zero digit. Yeah.
So when it has a decimal, you start on the left side, then it doesn't, then you start on the right.
Exactly. That's another way of saying if you don't want to say Atlantic and Pacific. Absent, present. United States. Everybody with me? We know how to say how many significant figures there are, yes?
Yes.
Last thing. First is you got to understand significant figures. Second is you got to be able to recognize how many significant figures there are. Now, before I get to the third thing, when you put a number in scientific notation, you include all of the significant figures. Okay? So if I'm going to put this in scientific notation, this number right here is going to be 4.107 times 10
0.
to the 0. This one, 4.00, I'm moving it right here, times 10 to the minus 2. This one, 4.10 times 10 to the minus 2. In scientific notation, you include all of the significant figures. Yep.
Why is there only 3 significant figures? For example, in the first one, when we know that zeros go on 4.
Where? Which one?
For the second one, we know that there's going to be zeros after that. You just look at the number. You just ignore the infinite zeros after.
Start on the Pacific side. This tells me that this is just a placeholder.
Okay.
That's all this is, a placeholder. This is just a placeholder. This is a placeholder, placeholder, placeholder. Because I don't know exactly. I didn't have something precise enough.
Okay.
What about the zeros after the 2 zeros after 4 in the second
That's what I
one?
was talking
Those
about.
are significant.
No, like, but if there's zeros after those 2s, like,
Like
a third and fourth
0.04.
There
zero.
would be.
0.0000.
This zero and this zero.
Okay.
This zero tells me that I knew it was exactly 0. It came to 0. This one is my estimate. If this was a measurement, and this was 0.4 right here, and this was 0.5 right there, and this thing was every 1/10 of that, okay? Then my measurement would go right to here. And it would be 0.4, and the next thing would be 0.40. This reads 0.40. Yeah.
How come the 3 zeros and the 42,000 aren't significant on the other side?
Right on this?
Yeah.
Because these are just placeholders. This tells me that these right here, the thing I used to measure this didn't measure to the accuracy of tens, hundreds, or thousands. Yes? Ones, tens, or hundreds. Told me it didn't. Yes.
Does that mean that the 2 is estimated?
Yes, this too is estimated. Okay, here we go. Now, how do we use these? How do we use these when we are doing calculations? Okay? If we multiply or divide, can they see that up there?
No.
Do
All right.
everything that's like upper thigh to like your glasses. Basically.
Can they see right here?
Yes.
All right, multiply or divide. Forget it, I'm not writing it. All you do is your answer has the same number of significant figures as the least number of significant figures in any of the things you multiplied or divided. So your answer has the least number of sig figs as any of the components. For example, let's try this. 4.78 times 3.9. You guys do that on your calculator. 4.78 times 3.9. Everybody do that real quick.
18.6.
What do you get?
19.
No, what does it say on your calculator?
18.642.
It says 18.642.
Yeah.
When you do these, write them out. Write down what your calculator says. Now put this in significant figures. This has 3 significant figures. This has 2 significant figures. So what's your answer going to be? 19. So your answer is going to be 19. Dividing is the same thing. 4.78 divided by 3.9. What does your calculator tell you?
1.2256.
1.2256, whatever. You know it's not as accurate, as precise as that. It's only precise as 2 digits. So what would your answer be? 1.2. If you are adding or subtracting, if you're adding or subtracting, you go to the least number of decimal places. For instance, I have 14.2 plus 19.71 plus 14.99. Add all those up. Add those up and tell me what your calculator says. So it says 48 what?
0.9.
0.9, is that what you count? Well, it should say 48.90, right?
I have 48.9.
Now, you can only go to the least number of decimal places. In this case, this has one decimal place, so your answer has to be that, 48.9. If you, how about this? How about if you're dealing with this? How about if you're dealing with 4.3 times 10 to the minus 1 plus 3.7 times 10 to the minus 2. Can you do that? How would you do that? Well, I find it a lot easier to change these to, I can either change them to the same scientific notation or just write them out as whole numbers. Which do you want to do? Whole numbers? So this one is what? 0.043? And this one is 0.0, I'm moving to 0 what? 0.037. Yes? No, I think it's, I went one wrong place, yes? It's like that. Okay, so my answer is going to be what? I add these together, I get 0.467, but I can only go to this decimal place, so what's my answer? 0.47. Did you read about this last night?
Yes.
Pretty confusing. Tough stuff. We know about rounding. I assume you know how to round, yes? What do we say? If it comes to 5, what do you do? Round it up. Round it up. Now, finally, very important. When you do this problem, when you do multi-step problems, you don't go to sig figs each step. Okay? You just go to sig figs at the end. So in other words, what could happen is, if you go to sig figs at each step, you might round up in one step, then it goes to the next step, you round up again, so you get an answer that's way off. Multi-step problems, you round at the end. Yeah?
What if you're multiplying and like adding in one problem?
We know how to do those, right? Do we know how to do those? What do you do first?
Multiply and divide.
Multiply and divide. What else if it's inside a bracket? You do that first, then multiply and divide. Okay? You're going to have a bunch of these practice problems to do. A little bit of reading, a little bit of stuff. But hopefully you did good. You guys at home? You guys did great at home. Hopefully you understand this. Next time I see you will be taking a assessment, yes?
Is it a quiz or a test?
It's an assessment. What do you want to call it?
Assessment.
Test, quiz, final exam, whatever you want to call it, I'll call it that. You want to call it a grace, we'll call it a grace. You know? If you need to see me before then,
Is this stuff
you're
on
screwed, right? Because I don't see you till Wednesday. Email me, maybe I can see you in the morning beforehand. Yes?
it? This stuff isn't on it though, right?
What? This stuff, sig figs, scientific notation, is not on it. No.
Is
Precision.
conversion factors?
Conversion factors, yes.
If we have like a conversion factor that comes out with like a long decimal point, should we just round it?
Well, right now, you don't, yeah,
Yeah, okay.
yeah.
Should we be memorizing all these different like, liters to grams or something like that? Or will the...
King Henry died while drinking chocolate milk, yes?
Yeah, but do we need to memorize like the different conversion factors? Like, like obviously like 1 centimeter cube equals 1 milliliter.
That's the only one you gotta memorize. We good? Turn this off, not pounds to gram or any of those.